Hey everybody, this is Larry. This is Friday, October 4th, but we're doing day 5. I guess it's Saturday actually almost because it's just past midnight here in New York. But hit the like button, the subscribe button, join me in Discord, let me know what you think about this one. Today I did 6 miles, but I also got this thing. I just want to show it off a little bit. I don't know. I'm really not into, I used to play a lot of video games growing up, as people do. I'm going to age myself a bit, but my friend finally I think like a couple of years ago, and feel free to leave in the comments your opinion or whatever. Maybe this is not that interesting, but I've been just kind of, it's just been in my head the last couple of days, is that, like a couple of years ago, I think I was looking up, or someone was linking me something, or maybe it was in Kickstarter or something. All these like retro handheld things. And I was like, oh, okay, but I'm not going to spend $200 on it. Well, two things is that, well, one is that I run so much. I ran 6 miles today, but I run so much that I need new shoes every month and a half, which is kind of crazy. And it's like $150, so it's not even cheap. So I don't know. Whoever tells you that running is cheap, maybe they're not that hardcore. But in any case, but anyway, going back to retro gaming, which is why I brought this up, and feel free to skip this. I'm just kind of like nerding out a little bit. Feel free to indulge me. I finally bought one of these thingies. And was it called and Ambernick, something like this. Yeah, I bought one of these things. It's like $60, which is, the cost of not that much shoe, if you will, and also like 2 or 3. In New York, it's like 3.5 Chipotles maybe. So I don't know, but I've been playing classic Super Mario World, and it's kind of crazy that a lot of my, like, you could fit my entire childhood on a $60 game thing. Not just my childhood, but all possible childhoods with every possible game pretty much, right? And I didn't even like buy a new memory card or anything because, I have a lot of photography stuff, so I just used one of my smaller cards that doesn't fit that much anymore. And yeah, kind of crazy times, kind of amazing. But yeah, that said, this week I'm up to 37 miles. And I have only another 24 miles to go this week, so we'll see how in the next 2 days. So I gotta wake up early now that I remember. Anyway, though, let's take a look at today's problem. We have 567 permutation and string. Also, let me know your favorite retro game. Doesn't have to be that old, but I don't know. Let me know your favorite retro game. Given 2 strings S1 and S2, return true if S2 contains a permutation of S1 or false otherwise. Okay, AB, substring. Substring. Remember that substring is not a subsequence. So that means that basically, in a brute force kind of way, and I know that brute force is not fast enough because, N and M is 10 to the 4th. But if we were able to do a brute force, what would that look like, right? Well, what would that look like is that we would take every substring of S2 and then compare it, right? For example, maybe we would have something like, let's say this one, and then AB, we go, okay, well, is this a permutation? No. Is this a permutation? No. Then keep going, right? Actually, I guess here is yes. But you can also already see that if this is the case, and it's not always true necessarily, but one thing to know is that the characters, the number of characters have to match. So it feels very natural to at least give it a try with sliding windows. And sliding windows is the idea behind sliding windows, and at least for fixed width stuff, I've been pretty okay. So I've been like really bad on the last contest with the sliding window, right? Because that was more of a variable width thing, and I didn't have my head wrapped around quite well that day. But for fixed width, right, then now we know that every time we shift to the right, and we always shift to the right exactly 1 because that's how they need to match up, then it just equals to, another way to think about it is that this going to the right is going to be equal to, this is let's just do another example. So something like this, right? It's going to be dBA, moving to the right is equal to this plus an O, and subtracting a D, right? The D being the leftmost character, and then now you Those are the incremental operations, and now you have BAO, and then you compare that to ABC. Of course, there's also another thing is that if two strings have the same width, how are they permutation of each other? Well, permutation just means that the order doesn't matter, right? Permutation, and you could kind of, I don't know, I'm doing my permutation dance, maybe not. And it really just means that, yeah, the number of counts are the same, right? Like, but you have the same number of A's, you have the same number of B's, you have the same number of C's, and that's it, right? All the way through, obviously. And in here, right, you can just say, the reason why you can do that is because, let's say you have to, you can do it one character at a time. For example, you have BAO, you go, okay, how many B's do I have? Okay, one B. How many A's do I have? And then so forth, and you subtract one, right? So that's why only the counts matter. Anyway, so okay, just sliding window. Let's say I don't like n is equal to the smaller number, but I don't know. Let's just go S1, S2, or N1, N2 is a little bit less ambiguous anyway, right? And then now we have a left is equal to 0 for right in range of N2, right? And then now after we increment, then we want to say, okay, there's a window, right? So maybe F1 is equal to the frequency table of S1, and F2, maybe F window. Well, we haven't processed it yet, right? So okay, so then now F window of S2 of right, we increment by 1, and then if you can write this in a number of ways, and for today, for this problem, and for people who are more advanced, feel free to make optimizations and practice your optimizations. But for me, for this one, I'm going to do it the dumbest way possible, which is, well, with F1 is equal to F window, which looks pretty innocuous, like it looks pretty safe or whatever, but actually it does it by a key by key, value by value comparison, which in this case, not so bad, only because we have up to 26 characters, right? We have A to Z, 26 characters, so this is just a 26 operation thing max. The reason why I point that out is that, and this is O of A, or O of alpha, where alpha is the size of the alphabet. The reason why I point it out is that because you could have a similar idea where you have these strings are numbers, for example. If you have numbers instead of strings, then these strings can go higher than 26 because you may have more than 26 unique numbers. But in any case, for this particular problem, because you only have 26 alphabet, or alphabet size is 26, this should be good enough. So if this is the case, then we can return true. Otherwise, if we try everything and nothing works, then we return false. Of course, I lied a little bit because we have to. So we've been sliding in, but we have to slide things out, right? So yeah, so sliding out, if right minus N1 is greater than equal to 0, then we slide this one out. Well, you can say maybe left is equal to something like that, I suppose. Yeah. And yeah, we could just give it. How did I get a wrong answer last time? Was I just lazy? I guess I just have an off by 1. But yeah, I mean, I know that there are optimizations here. There are a few optimizations, in fact. But yeah, I mean, no need to prematurely optimize. I'm gonna keep it stupid today. Keep it simple. And yeah, so this is going to be linear because we go over this O of N2. This is O of N1, also linear, right? This is O of 26. O of alpha is this one. So it's going to be O of alpha times N2 with the size of S2. Yeah, that's all I have for this one. I'm going to keep it simple. I'm not going to do a bonus problem today. Going to get some rest. And by rest, I mean play video games. But I do have to wake up. When do I have to wake up? I don't know when I have to wake up, but I have to wake up pretty early to do a early morning one with some friends. So yeah, that's all I have for this one. Thanks for watching. Stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye bye.